and start recording. So, okay, so can you give a brief intro about yourself?
Right. Okay. Hey guys, Kevin. I graduated last year in applied math, and I've been applying to jobs for about 8 months now. I've had a few interviews, but I think that I have room for improvement. I'm here to see how I can do on the medium stages, I guess.
Okay, yeah, that sounds good. Okay, so the first problem, you're going to get a string. And the string will consist, just to keep it simple, of only lowercase letters. And basically what I want you to do is tell me if this string can be a palindrome with up to 2 removals. So just to give you an example, let's say our string is like ABA. This is already a palindrome, so this will be true.
Yep.
So we have ABCA. This is also true because we can remove either the B or the C. Say we have ABCDA. This will also be true because we can remove just 2 of the letters. And then obviously if I have ABCDEA, then this will be false because I can't remove enough. So feel free to ask me anything you need to or any clarifying questions.
So the string, you get a string and you can remove any 2 letters, and if it's a palindrome after 2 removals, then return true. You don't have to remove all the letters, and I guess you always ask, can the string be empty?
It can be empty, yeah.
Okay, and does an empty string count as a palindrome?
So what do you think?
Yes, I think it does.
Yeah, I agreed.
Okay. I think I should be writing stuff here. Okay. Oh, this is Vim controls, actually. Let me just change that off.
Okay.
Okay, so let me think. So I guess when you want to check if something is a palindrome, you usually want to start from like the middle, right? And since we're not finding a palindrome inside or like as a substring, but as the whole string has to be a palindrome, I guess my first thought is that if you just cut the string in half and then you know, iterate outward, and then if you come across like you know, something that that doesn't match up, you try removing it greedily, I guess, and then you proceed, and then you can try that one more time, and then you can proceed again. And if you encounter a third mismatch, then it's not possible. I wonder if that makes sense. Does that sound like that makes sense?
Or so can you give an example?
Cover? Yeah, all right. So I'll just take this example right here, A, B, C, D, A, right here. We will start at the middle, which is right there. Okay, I mean, actually, I'm going to start with an odd case to begin with, and then we'll consider the even case after. Right, so right now in this case, we start at the middle, which would be A, and then we'll just iterate outward and then check like the mirroring position. And in this case, you know, one of them, I mean, we have a mismatch, so we tried deleting one and then seeing if it works. And if it doesn't, we delete the other side, see if it works. And if it doesn't, then...
Okay, so I see what you're saying. So my question to you is, if we go back to the original string, right? So let's say like you're like, oh, the middle is fine, obviously. Now you're like, oh, the C and the D don't match, so I'll try deleting one of them, right?
Yeah.
Well, you can have a case where you actually need to delete 2 on both sides, and they might not be in the same spot. For example, say we have this. Now, you could actually have deleted this. And so you're not necessarily going to be deleting, like, once you have a mismatch, you delete one and then you delete the other. They might be anywhere in the string. Does that make sense?
Yeah, that makes sense.
So how can we handle that as well?
Okay. So what if instead we worked from the outside in?
Okay.
And whenever they aren't the exact same, then you just add it. You just skip to the next one. I should really be writing stuff down to make sure it makes sense for me even.
Okay.
So we start from the outside in, where we maintain, I guess, 2 arrays. And then in this case, we have A, and then next we have, if we look at both sides, we have a mismatch, and then how would you determine which side you want to delete from?
So you have AE. Oh, so this is, so you're like adding, why are you adding items to arrays here?
I'm just counting, I'm just looking at the letters from both ends of the array. And
do you need arrays to do that?
I guess you don't. You can just look one letter at a time and store the letter, like in O1, I guess.
Right. Like you can just have like pointers instead, right? You can have like a pointer here and a pointer here, so
Yeah.
you don't need to store everything. Okay, well, let's keep going. Even if you have arrays. Okay, so what would happen here? So here you
yes.
have a mismatch, right?
You have a mismatch, and then how would you decide which one to remove? I guess you could just try removing one, the other, or both, and then kind of branch off. But I don't know if that's over engineering for this problem.
Okay, well, so how would the branch off look like? There is no such thing as over engineering, so let's just come up with something that works, and then maybe we can make it better.
Okay. Well, I guess the branch off would look like, since it's only 2 removals at most, we can kind of almost hard code it where we just store, one removal, the other removal. So we just do. We have like a 2. Not 2. Sorry, it would be 8, right? You would have 8 possible paths. I don't like this solution. This is not. It's just confusing me. Okay.
So you don't know for sure like what letter you need to remove, right? Like in this time. Like I can give you examples where it's E, it's B, it's like you don't have to figure out what's the second letter, but like the first letter to remove might be either one of these, right?
Yeah.
So how can we make like a generic solution that handles anything and then also keeps track of removals? Like, yeah. And yeah, there's not that many branches, because like in this case, if it's a different thing, you have to try one or the other. That's only 2 branches. And then whenever you have some more, you only have to try a couple, So it's not like this infinite maze of branches you have to try, because there's only 2. So how can you write something that like is clean, I guess, that handles this?
Well, I mean, in terms of just getting it to work, maybe I would just have like honestly, I would have like a 8 by length string array, because like at most it's like 2 to the 3 possibilities where you remove or don't remove at a given
I see.
encounter.
So think about it this way, right? So
Yeah.
you said you start at the ends, and then you compare character by character. So like you compare, and if they're the same, then you like move them both up, right? And then you compare again, and so on. So let's say you get to this case where there's this difference. Well, I don't know which one I need to remove here, right? I don't know. Like it's this one or this one. But either one, you can take one of these and you can move them up, and you can say like I just removed a letter. Does that make sense?
Yeah, that makes sense.
So how can we, if you think of it in terms of like sub-problems, how can we account for these things? Like what do we need to know to get a solution?
Oh, okay. I mean, you could recursively like call the solution again on the case where you move in the left pointer, the case where you move in the right pointer, and the case where you move in both pointers. And in the first two cases, you would subtract the amount of removal. You would subtract one removal from the amount of removals you have left. And in the second, or the last case rather, you would not be able to remove anything else.
Yeah. So can we have that like solution? Does that make sense to you?
Yeah, that makes sense to me.
Okay.
Okay, and the time complexity of this would it would just be O of n, right? Because at most you recurse 3 times. I mean, like if you in the second case you recurse 1 extra.
Yeah. So you said you can have you can remove one letter, you can remove the left or the right or both.
Yeah.
So one of these is actually unnecessary. Can you think of which one? Like 2 of them will handle the third.
I mean, maybe if I did an example, like, let's see. I mean,
sure.
All right, let's just say we remove this one. Yeah, it's fine. Instead of that one. And then we call the sub-problem on this. Is that the same as removing this one and calling the sub-problem on this? I mean, I don't know if it is.
So basically, like, if you remove one letter, you move one pointer up, right?
Yeah.
So then, if in that recursive case, like, let's say, like, this is a sub-problem, clearly, right? Where you have one more removal left.
Yeah.
Now, what if I just remove the right letter? Now I have the same sub-problem as if I removed both in the initial one, right?
Oh, true. Okay.
So, yeah, so you said it would be linear?
I mean, like, yeah, I think it would be linear, right?
Well, yeah, because like,
yeah,
if you have a place you need to remove letters, you can either remove one or the other, and recurse, and then any other place you need to remove letters, you can only remove one or the other and recurse. So you can't do it very many times. So yeah, I agree, it would be linear.
Yeah. Okay.
Okay. So do you want to code this then?
Okay. Yeah, I think that I can go ahead and code this.
Okay, sure.
All right. Def palindrome with removals. This takes. Well, actually, this is we're gonna be recursively calling this, so it's going to also take in a parameter k, where k is equal to 2 by default, I guess.
Okay.
S string s. Okay. Right. So character 1 is going to be equal to you know, the first string, first character. Oh, actually, if len s is 1, we just return true.
Okay.
So that covers the case because right now I'm going to check the last letter. And actually, I'm not sure if the string is length 1 in Python and then I call the last letter, it's just going to give me the same letter both times, right? And then it would still return true. Okay, but anyway, it doesn't hurt to have that first case. If car1 equals car2, we're gonna recurse. Oh, and there's also the even case, which I should probably make sure not to forget about.
What is the even case?
If there's an even number of letters at the end.
Oh, like 2?
Yeah, 2, just 2. Yeah.
Okay.
Actually, I don't even think that will have to be a special case, but anyway, we're going to call this recursively on from the first one to the second last one. Actually, we have to we want to early return if it's just 2 characters left. Also, if len s equals 2, return true.
Okay.
And then in this case, we still have 2 left because they're equal to each other, so that's fine.
So do you know how Python substring works? Like, does it include the first index? Does it include the last index? Like,
it includes the first index, but not the last index, right?
Okay.
Oh, right. So that's why it should be like this.
Okay.
Okay, and then if it's not equal to, then we want to return else. I mean, we don't need this else, but we're going to return calling it again on removing just the first one, and this time we have 1 removal, or we're gonna call it last one, also with 1. Well, actually, we talked about how we don't need to do this, but I don't think it hurts to just have this. Yeah, I did. So I'm just gonna where we remove both again, but also but this time with the 0 removals. And actually, I just realized that it should not be 1, 2, or 0. It should be k minus 1.
Okay.
K minus 1 and k minus 2. And also, if k... Actually, we can just do this way at the start. If k is less than 0, which means we remove too many, return false.
Okay.
And I think there should probably be some more conditions that we return false. But oh, I mean, I don't know if this is necessary. We'll see when I dry run it, but like, I guess if it's not very clean, but you know, if if k is equal to 0, and I should move this down here. K is equal to 2 and car 0 is not equal to car 2. Return false also. Okay. Yeah.
Okay, so it looks like so it's not defined. Wait, why is that? That's weird. It's a,
Yeah,
did you
I'm
use
not-
the
I'm
wrong
not sure.
name or something? I think you used the wrong name. Yeah, because if I highlight this one, it doesn't show the other one. So you did something.
Did I make a typo that I can't see?
Yeah, you're a palindrome. That's why.
Oh. I wrote palindrome for one of them also.
Okay.
My bad. Okay. Let me just fix that.
Sure.
I can't select the text on the bottom row.
That's weird. Okay, here you go.
Okay.
Okay, so yeah, maybe let's go through an example with what you have.
Okay. Right. So, I guess we'll just do this example that we have up here. So we're gonna check the car 1 is going to be equal to A. Car 2 is going to be equal to A, obviously. They're going to, the first two conditions are not going to return. K is not equal to 0, so that's not going to early return. And since they are equal, we're going to recurse on the inside. So now we have this, and car 1 is equal to B, car 2 is equal to E, and once again, no early return. This time they're not equal to each other, so we're going to return any of the 3 recursive calls if they work.
Okay.
I mean, in this case, we already know that none of them work, but
that's fine. I think we can move on. I think you get the gist of it, and I want to give you time for the second problem. So we'll just move on to the second problem.
Okay.
So for the second problem, okay, so you're given an array of numbers. Okay, so let's just say the example is like 1 and 3. So basically, what I want you to do is I want you to make a class with one function.
Okay.
That will be called a bunch. So this is the function we want to optimize. The function is going to be called pickindex. And what pickindex does is it gets a random index from the array based on the weight of the number in the array. So the way to calculate this is the number in the array over the total of the array. Okay. So in this case, because we have a 1 and a 3, the first index, so index 0, should be returned roughly a quarter of the time. And index 1 should be returned 75% of the time. So imagine like our test case for this that we don't have to write is we just call this function like 1 billion times and we just have some like room for error. I guess you did like ML and stuff, right? So you understand this, like, you know, we have like a 1% statistical error or something, and if it passed, that means our function's good.
Yeah, we want to write a probability density function, basically.
Yes.
Okay.
So what are your thoughts?
Yeah, my thoughts are that you want to. I think I probably did this at some point, so I should be able to solve this. It's just down to my communication.
Okay. We can also skip it if it's like too fresh in your mind. Like we can do another problem if you want to.
No, I think it's fine.
Okay.
Okay, so yeah, basically you want to you want to do like you want to find like the prefix sum of the array, right? And then so the prefix sum of this one is going to be, or actually what I do is I attach 0 to the front, and then we do a prefix sum of everything else. So then we
Okay.
have 1, and then, well, 4. So then we get 0, 1, 4. And then basically now when we generate a random number between, oh, wait, hold on. And then we need to divide everything now by by the total number of numbers there are. So I mean we sum array. Get sum of elements in array, which is going to be 4, and then we divide every element here. So we're going to get sum to obtain 0, 0.251. And now when you generate a number between 0 and 1, it's going to be between 0 and this number, 25% of the time, and it's going to be between this and that number 25% of the time, assuming this is uniform. And that would be the end of the problem, I believe. So does that sound good?
So I have one small thing. So decimals aren't super accurate because like this is 25, but like what if we had some other decimal that's not super accurate? So ideally we want to avoid decimals if possible. So can we do that in some way?
Oh, really? Okay.
Yeah, like in computer science, decimals are just obviously this would work, but we could do this without having decimals. So decimals don't have like perfect precision. So yeah, how can we do it without using decimals?
Well, then I guess instead of dividing by the sum, we just multiply our number by the sum.
Okay. So we generate a number between 0 and the sum. Okay. So in that case, so we generate a number between 0 and 4.
Yep.
Okay. So we generate a number between 0 and 4. How many numbers are there total we can generate?
0, 1, 2, 0, 1, 2, 3. I guess it would be exclusive of 4, but
oh, be exclusive of 4. Okay. And then basically you're saying like whatever number you have, like how are we going to figure that out? Like let's say we get 3, then how do we know which one it is?
You place it into here using binary search, like where it would go.
Okay, that sounds good. And so what would be the time complexity of like this pick index function?
Well, so the class itself does all this stuff, beforehand, right? So it's not part of the pick index. The pick index would just be log n, then, because it's just one binary search, and I don't know the time complexity of generating a random number, if that.
Okay, we'll say generating a random number is of 1.
Okay, so I think it would just be log n.
Okay. Yeah, so I think this makes sense to me. So let's code this then.
Okay, sounds good. Number picker. Weighted number picker.
And how familiar are you with Python, by the way? Do you use it a lot, or do you just use it for coding interviews?
I use it pretty much for most of the things that I do.
Okay.
Why do you ask? Am I bad at it?
No, I just want to make sure like I give you fair feedback, because if you say you use it for everything that you do, then I'm gonna like criticize harder,
Okay, fair enough. I think that I probably should.
Okay.
Should be comfortable enough with it for this. All right, so okay, wait, there's no brass braces for classes. I guess that's what might have been what you were referring to. Def init self. Wait, so what are the what am I given for the
So you're given an array in the constructor.
Okay. And so we want to self.pdf, or actually first we're going to do prefix equals 0 plus accumulate. This I might have to import something for this, so I'll figure that out later. All right.
Okay.
I actually don't know where accumulate is imported from, probably because I don't use it outside of coding problems.
Okay.
I mean, it's not that hard to write a prefix function.
Yeah, so let's just write a prefix function then if you don't know where to import accumulate.
Okay, fine. Prefix equals 0 for times len array plus 1 for I in range 1 len array. Actually, just I wanted to do a check. Prefix I plus 1 equals yeah.
Okay.
I think that should do it. Once we have our prefix array, is that the only thing we need? Oh, also I forgot this stuff. I think that's the only thing we need. Okay, and then def pick. I don't think pick needs anything, does it?
No.
Okay, right. So, and then we generate a number equals random number equals random. Honestly, I should probably know the random API a little bit better. From random, maybe just import random. Maybe it's randint. Anyway.
You can look it up if you need to.
Random API. Yeah, okay, it's random. From 0 to right. I also need the total. But the total is just the last element. Self.total equals or not. 0 to self.total, and it's exclusive -1 because I think that it is inclusive usually, according to this thing that I've looked up.
Yeah, so we'll say it's inclusive. Also, if you hover over randint, it tells you it's A to B including both.
Oh, cool. I didn't know that. Why does it say I'm missing a parameter? I think
because you need to give it 2. So it takes in an A and a B.
Oh, really? Okay. Okay. And why is self not defined? Whatever.
Okay, so you have a random number, and then what?
And then we want to search for where it would be in self.prefix. And we can do that using the bisect library, which is so conveniently provided for me.
Oh, but we can not use that too, so we'll not use that.
Oh, man. Okay, fine. We will implement our own binary search. L equals 0, R equals len prefix minus 1, self.prefix. Oh, why does it say self is not defined? Did I define my init wrong?
You did not define your init wrong. So if you hover over pick, it tells you some stuff.
Oh, thank you. While L is less than actually, I think we can do I'm really bad at this part. If random number or if it's less than m, if it's less than m, embarrassingly, I need to use like my fingers for this, but if it's less than m, we want to shift the search window to the 1, 2, 3, 4. If random number is 2, we want to shift the search window, or sorry, if it's 1, we want to shift the search window to the left. It's too small. Okay, and if it's equal, then we found it. And in this case, we have 0, 1, 2, 3, 4. 0 goes into the 1 category, and or 1, 2, and 3 go into the 4 category. So if it's equal, actually, we want to return the number to the left. Yeah, okay. Return.
Yeah, I guess so. Basically, you're saying like if you have 0, 1, 4, like in this example,
yeah.
If you get a 1, you actually want to return the number to the left.
If we are to the right.
To the right. Okay.
If you get 1, you want to return 4, right? Because 1, 2, and 3 belong to 4, while 0 belongs to 1.
Yes, that makes sense.
Yeah. Okay. So we want to return n plus 1.
Okay.
And if it terminates without finding it, then that means that L is if it terminates without finding it.
Yeah, if it terminates without finding it, there's still always an answer, right?
Yeah. I'm just trying to figure out where what L or R will be equal to, and then we should be able to get the answer from there. If it terminates without finding it, then L and R should be like will they be equal to each other? I think it'll be L. L will be where it needs to be. We want to return L plus 1.
If it terminates without finding it, L and R won't be equal, because if they're equal, you stay in the loop.
Yeah. So L will be greater than R, actually.
Okay.
And so if L will be, I mean, I guess L will be potentially then. Well, I mean, in real life, I'd probably run it at C. But I think since R is going to be the smaller one, I would return R plus 1 here.
Okay. Can we do a dry run maybe of where you don't find it and then you can test? So maybe have a couple more, like maybe more than 3 numbers, like,
Sure thing.
6 numbers or something, and then you can test if it works.
Okay. Sure. Tick, tick, tick. Okay, so if our number array is 1, 2, we can just do this. Then prefix will be 0, 1, 3, 6, 10, 15.
Okay.
Okay, and then we want to find, we generate a number, and the number is equal to, I don't know, 8. So we would expect it to return 10.
Mm-hmm.
Oh, wait, but n is an index, so that's not what we want. We want to return prefix. I mean, okay, I might come back to fix that, but just writing there, that is a reminder for me here that we want to return prefix, not the index. But yeah, so basically, L is going to be 0, R is going to be the length of the array, which is
so you can just do this, which will make it a lot easier. You just have the 2 pointers, and then like
cool.
you can just move them.
Okay, I'll do that. Okay, so then M is going to be the middle element, which is of course going to be, in this case, the smaller of the 2 middle elements.
Mm-hmm.
This. We'll see that 8 is bigger than M.
Mm-hmm.
So we're going to search here now. And now M is going to be here. 8 is going to be smaller than 10. So we're going to be just on 6 by itself. And then
so actually I think so your middle number was 3, right? But the random number is bigger than 3. So you would hit oh yeah, okay. So you're saying actually oh yeah, so you would hit this case, right? Okay, so that makes sense. I think actually I was wrong about that. Okay, cool. Let's keep going.
So we would get 6.
Mm-hmm.
And then that's too small. So at this point, L and R are both going to be at 6, and then it's going to be too small. We're going to run forever. I mean, I think that and then if M or 0, 1, 2, 3, R is going to be or L is going to be equal to R, so M is going to be 3 plus 3 divided by 2, which is 3. We're going to be too small, or going to be too big, so we're going to be into this case. L is going to be M plus 1, so it's going to be 4, while R is still going to be 3, which is actually exactly, then the loop is going to terminate, and then we're going to return prefix R plus 1, which is 3 plus 1, which is 10, which is exactly what I wanted.
Okay. Okay, so we're at the time limit.
Okay.
So how do you think you did? What do you think you need to improve on? What do you think you did well?
I mean, yeah, my problem solving for question 1 definitely left a lot to be desired.
Mm-hmm.
I don't know. I feel like I calmed down quite a bit. Like after the problem solving actually started, I was able to focus and not get distracted by my emotions. I think I made a lot of unnecessary sounds that might have been annoying for the interviewer.
I mean, I don't really care about that, but yeah.
I mean, it's not. I mean, like subconsciously, right?
Sure.
I don't know. What do you think? I mean, I guess you can tell me after.
Okay. Okay, yeah. So let's just get into what I thought. So realistically, this is probably like as easy as it gets for like a competitive company, I would say. Like
Yep.
And so my goal for the first question was like, I'll give you the first question. This is like basically a text screen question that you would get for, like a big company. And then if you just like crush it, I'll give you something harder. If you struggle, I'll give you something around the same. And so I felt like the first one you struggled a decent amount. So you basically were trying to do like an inside out greedy thing, and it doesn't really work. And ideally you can just point out these things yourself. So I had to give you a decent amount of hints where I was basically like, well, if you have literally this setup and this happens, like, how does this look like a recursive call? So I feel like I gave you a decent amount of hints. So ideally, I would say for this level of problem, my hinting should be like minimal or none. And yeah, and then you said it was linear time. You also had a decent amount of issues with your code. So for one, I do agree having code like this is not great. Like this could be a lot simpler. So you can basically just, for one thing, you recurse that every character, which is not great because you could have just used like pointers. Because basically, if your like, you can basically just do something like, while left is less than right, if they're the same, then you just do like this, right?
Oh, that's true.
And then you don't need to recurse unnecessarily. You
Yep.
also have a bunch, like, checking for too many edge cases that could just be like you could probably get rid of this and solve it in like way less lines and way less checks and just like make it a lot simpler, right? So if you're checking for 10 things but you only need to check for like 3, then that's just like not then that's not great. The other thing is, so actually you're doing string slicing at every 2 characters, which is you're making a new string. So this wouldn't be linear time, this would be n squared.
Oh, okay.
And so at least I think so in Python, right? Like you're doing a slice at every character, and then like basically, like imagine you have a string of like 1,000,000 characters, you're doing a slice every 2, so you would basically just like make a new thing every time you go down 2 characters. And that would be n squared. So it's important for you to know that and like write code that goes with the time complexity that you picked. But your overall solution did work. It was just, you could, like I said, you can clean it up, and I think there were enough mistakes for this level of a problem that I would rate this as like a lean no higher.
Okay.
And then for the second problem, so I don't know, maybe you've seen it, maybe you haven't. You came up with a prefix sum really quickly. So I was like, okay, this is going to be great. You're going to crush it here. And then it kind of went a little bit downhill once you started to code. So for one thing, the reason I asked if you know Python or not, like I'm almost certain a class in Python is supposed to be like uppercase. So
is that a convention thing?
Yeah, so I would expect you to know Python convention if it's your primary language and you do everything in it.
Fair enough.
So that's why I asked. Like if someone didn't use it, it's fine. If you say use it for everything, I would, like if I was hiring like a Python engineer, and I mean, even worse, some people have had like, oh, I don't know how to write a class, I only copy from LeetCode. You definitely didn't have that, but if you don't follow like maybe you can argue like like camel versus Pascal or something, but if like a class is supposed to be uppercase and you make it lowercase, I'd say that's like a not great for your primary language. So then the next thing, so you did come up with like the prefix sum correctly and that, but then yeah, you really struggled again in the binary search. You were like, okay, I have to like really think about this. Like I want to make sure I'm not off by one. Like how do I do all this stuff? And you actually made your solution a little bit, I would say, like overcomplicating. So the easy, I mean, I guess you can write it however you want, but basically it's hard for me to know if this works, right? Like by looking at the code as the interviewer. So if you have like almost no certainty, then I would say even if it does, because you don't really know if it does, then that's not great. So ideally when you code this, like you're very confident that what you say works, and then you go through the dryer and you're like, oh yeah, and it worked just as I expected. So I would definitely like. So one thing I do, I guess maybe this could help you out for like a binary search. So you're basically saying you don't know if you need to return like the left or the right or whatever, right? Like you always get off by ones. So a really simple solution that I do and works for me because I had the same problem is I just have like a result variable, right? So I'll just make it like -1, and then I have like the while this. So you get the middle. So I can probably just copy most of this. So you get the middle. And then so I'm just gonna write it in like pseudocode. So if like this is true, like what I'm looking for is true. So like if value is valid, I will store it in my result, and then I'll like do the whatever, the left or plus or whatever. Let's say it's like this. Otherwise, I'll do the other one, right? Whatever that is. And then it's very easy, and then you just return result, and you don't need to know if it's like right -1, left +1, whatever. It's just always correct. So this helped me a lot, and this is like very easy to do, and then you won't get any of these.
Okay.
I don't know where this needs to be.
So
ideally, you try to like find places in your code where it's kind of messy and not super easy for people to follow, and you fix that up into things like this, where it's like very easy to understand, very easy to be you basically want to cut down all the stupid errors you can make, and you want to focus on the problem. Like if your complexity is not unnecessarily like complicated, it's very easy to make mistakes everywhere. And in a hard problem, you're not going to be focusing on the problem. You're going to focus on your little stuff. So you don't want to take like 5 to 10 minutes doing a binary search and having to figure out like all these things. So that's why I would recommend like all the code you write, try to make it like at the end of the day you're applying for like software engineer, not like algorithm solver. So you need to have like good code with like good time complexity, and it's like readable and like correct and stuff. So basically I said for the second one, some things you can work on is like variable naming. Like I wouldn't call things like L and R and whatever, like use real variable names in actual interviews, not like LeetCode. And then you talk through what you're writing, but definite not ideal situation where I'm like, oh yeah, you can't use bisect, and then you go and write a binary search and you're thinking about it for a long time.
What would you call like would you just call it left and right in this case? Because
yeah, exactly, left and right. Yeah, don't use like ideally don't use one letter names. Like on LeetCode it's fine, but in real stuff like don't have L right M. Like obviously people can understand what it is, but I would recommend using like more descriptive stuff. And it's not like it's that hard, right? So maybe M could be middle or pivot or whatever, but it's just like more descriptive.
Okay.
So I would recommend that because some people don't care, and some people will mark you down for too many. And then this can get really bad if you have too many variables, right? Like I've literally seen someone call variables like IJKLM, and I'm like, I'm not reading that.
Yeah, I agree.
So yeah. So
been there too.
Yeah, so I would say for the second one, it's probably like a lean higher, and then for the first one's the lean no higher. As I said, it doesn't really matter what you get here because I think your goal should be to aim for a strong higher, and like no matter how you grade it, that's not this. So that should be the goal for like mocks, and that should be the level you get to, and then like your results and interviews are in your control. So basically, no matter what like outcome you get in mocks, you should always ask like, what did I do worse, and what did I do badly, and how can I improve it for next time? So I think overall problem solving can definitely be improved. Understanding like the time complexity of different things, like that a string slice, or another really common thing people do is like they do like they'll have like A equals something. Whoops. they'll have like a equals something, and then they have a while loop, you know, or whatever, like for I in like a million. They'll do like a plus, like I don't know if you know this one. Like this is not also.
Oh yeah.
So that's another one people do badly. So make sure you avoid having things that like screw up your time complexity, because if you say it's O(n) and then your algorithm is actually O(n) squared, that's like not good. So so make sure you know how like all that stuff works, and make sure you know the fundamentals very well and can code them quickly. Like ideally, basically, you can do the easy stuff like a for loop. So like if I ask you to write a binary search, it should be like a for loop for you, and things like that. And for this level questions, even for new grad, like I would expect you not to need too many hints, because they're like pretty straightforward. So yeah, basically, I would say like do more problems. Obviously, you know, get over your nerves, like do enough. Like once you do enough, like the mock should just be like a conversation. You shouldn't be super nervous, and like ideally the interview is like that too. It's kind of hard for it to be, but everyone in the first couple is like super nervous. So I would say like for almost everyone, if their first onsite's like a big company, if they've never had an interview before, they're always just gonna like the nerves are just gonna kill them. So you just have to. Oh, yeah, go ahead.
Yeah, did I seem like particularly nervous? I mean,
I mean a little bit, but it wasn't too bad. It was like I told you. I think the worst I've ever seen was someone who was basically about to like cry or pass out or something, and I was like, "Are you like you're not in a fine emotional state to be doing this?" You know, like so
Okay.
that was like extreme.
Yeah, yeah.
So
It's
and
hard
I've
to
only seen it
simulate.
once.
Yeah, because like when I do mocks with my friends, like you know, I'm not like nervous at all because I'm so like comfortable with them. So it's really hard
Yes.
to put myself in a position where it feels real.
Yeah,
So this wax is
you're
really
not
good.
going to be comfortable with like the people you're interviewing with. So I would definitely recommend it's okay doing mocks with your friends for um like just reps. Also,
Yeah.
it depends where your friends are. If your friends are all the same level as you, it's going to be hard for them to give you constructive feedback. Like I've heard that from some people where they're like, "Yeah, I did mocks with my friends. I thought it was fine, and then I did a mock with you, and it was like a reality check."
Hmm.
So that definitely can hurt you. Where you need to do mocks with people that are like better than you
Yeah.
to get good feedback. And then yeah, like you're not, you know, like you're not going to be interviewing with your friend for a job. So that's the other reason why it helps to do it with people you don't know. You know, that will like criticize you and stuff like that, because that's just like that will help you.
Yeah.
So yeah, I would say if this was a tech screen for like an easier company, I'd say this would be like a pass. If this was like an on-site, I would say this would be like a fail. But either way, I think there's like clear takeaways of you just need to get better at problem solving. Definitely like work on speed, and then definitely work on like code quality, readability, that kind of stuff. Just like overall, like I don't know how many problems you've done, but I'd probably just do more problems, and then get to harder difficulty problems, because I'm fairly confident if I would have asked you something reasonably difficult, it wouldn't have gone well, which is why I asked you with the second problem that I did. At least that's my take from the first one. Because you struggled with the first one, I chose like an easier second problem.
Yeah. Yeah.
Yeah. So yeah, I would just recommend just if you said you did all topics. So have you heard of like Zerotrac or something?
Yeah. I have.
Yeah, so I would do Zerotrac, figure out where you are on there, and then try to like move up over time.
I think I'm at around like a 1500 on there.
And that's exactly where
Sometimes
I would
back.
guess. Yes, if I had to give like a number, I would guess that. So just for
Okay.
context, like I think the tougher things are probably in the 17 or 1800 ish. That's like that. That's like the maybe average-ish question. And I think basically the goal is like if you want to for sure I'm gonna pass. If you can get to 2K, it's for sure I'm gonna pass. If you're at 15, I would say it's almost certain you're gonna fail. And then if you're at like 17 or 18, then it's kind of like a 50-50.
Hmm.
So if you want some numbers, that's what I can give you there. You can also look up like tag questions and see what ratings there are and all that stuff.
Yeah. 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 I
And
do that for
so
sure.
I think the way I would recommend is look at the tag questions, look at what the harder ones for the company are rated, and then kind of like, okay, this is the hardest stuff I'm going to get asked. And then prepare for that level, because during an interview, you're going to be nervous, you're going to do worse or whatever. So, like, your calm problem solving ability should be significantly higher than what they ask you, in my opinion, to give you a
Yeah.
good chance.
Okay. And do you have any like anything to say regarding like when I get sometimes I'll get like a behavioral screen, right, where they just ask questions like, you know, are you legally allowed to work here? That sort of thing, like no technical stuff. And then like I'll get rejected at that phase. Like, is there anything like you can even do at that point, or
Are
like
you
is there?
legally allowed to work here? I mean, are you legally? Like, I would just say yes. I don't know.
I
Like,
mean,
what's
I
the...
am. I'm not getting rejected because I'm saying no to that.
Uh-huh.
I'm like just the example, like the HR questions that like they're just
I
asking me.
I see. I don't think I've ever been rejected on that. There are so I will say the thing that's in biggest control for you is technical performance. And that you should do as well as you can. I did have, you have a recruiter call and it just like sometimes doesn't work out. Like they're like maybe they're looking for something, I have something else. Maybe I have it the recruiter, like half the time they don't understand what the company actually needs. And that's pretty outside of your control. So like you might
Mhm.
have a recruiter call that like you're like there's nothing I could have done and there's probably nothing you could have done. So
Okay.
that you can do your best and like it just might not like you might just not be like what they're looking for or whatever, and it's like it is what it is. Those are pretty outside of your control. Um, but the technical part is in your control, and then the behaviorals that are actually technically focused, like what did you work on, how did you interact with people, leadership, like actual technical behavioral, that is also inside your control. I would say, yeah, for me the recruiter part is like the most variance, like you know uh shit can just happen. Like I don't know. It's like I honestly don't know what the, like. Sometimes it just feels super random. So the nice thing is for big tech recruiter, like by the time you get the call, they basically are like, yeah, we're moving on as long as this person isn't like crazy. So for startups, they are gonna like vet you during the call and stuff because they don't have like a dedicated process to do all this stuff. But yeah, in my experience for big tech, like basically every time I had a recruiter call, I had an interview. For startups, it can be, yeah, it can be kind of weird. So
Okay.
I think the main stuff is just make sure like if they ask you, do you have experience with stuff, say if you do or not. I honestly don't know
Mhm.
what the best strategy is there. Some people say like just say you have experience with everything and then be more honest in the hiring manager round. I just am honest like everywhere because yeah,
Oh yeah, of course.
and then whatever happens happens. Like, but yeah, I definitely think that one is outside of your control, like HR, recruiter, all that stuff. So, but the main
Okay.
thing is yeah, like if you should be doing as well as you can during the technical rounds because especially as a new grad, like almost all your interviews are just coding, right? You don't have any design, you don't have like anything else. It might be like a
Yeah.
little bit behavioral, but it's mostly like they're not going to ask you too much because you don't really have experience. So definitely the coding rounds are the ones that are most in your control and the ones you should be doing as well as you can in.
Okay. And do you have like ballpark figures for like how many people get like once you're at like the like I guess just like well, once you're at like the final round, how many people are you competing against really at that point?
I don't know how many you compete against, but I can give you some numbers of at least some of the ones I know. So, for example, I interviewed with a startup, and the guy said and I got an offer for that startup, and the guy said he interviewed 50 people, and one got an offer from initial call to offer. So,
What that one
maybe,
being you?
huh?
That
Oh,
one
sorry,
being
sorry.
you?
He interviewed 250, and five got an offer, and I was one of the five.
Oh, okay.
But this can be, the initial call might not go well, the text screen might not go. Like I think he did every round. So there's like, yeah, it was like initial call, text screen, and then an onsite, and then like he basically said like from initial call to offer was 1 out of 50, and I can give you a number for my team. So I think basically it was like 25% of the people passed the text screen, 25% of people passed the onsite. So it's like 1 out of 16.
Okay.
So it's definitely not crazy, and most people in reality don't know how to do basic stuff. So, like I thought the tech screen for my stuff was pretty straightforward. The on-site was okay. So, yeah. So, but I would say those are the numbers. Maybe like 5% get an offer, something like that.
All
Yeah,
right. Okay.
yeah,
Thank you. Thank you for your time.
yeah, yeah. I guess I'll add one last thing. So, also talking to people who like hire for like big tech, they're like most of the people who we interview can't do a binary search or a BFS or whatever. So yeah,
Oh, is that encouragement?
yeah.
All
So
right. Thank you.
okay, okay. Well, see ya.
Yeah. See you.